Hello, Calculus 1, our first remote learning notes. Follow along with your note page as we go answer the questions that show up, and you'll be good with these notes. So, reviewing today, solving quadratics and using the factoring that we were doing. Um, should be some quick ones here. Been doing this for years now. All right, solve x squared minus 5x minus 6. We remember factoring, so x squared minus 5x. And minus 6. Careful with that 5 and 6 on there. We've got x's all over the place. X times x is x squared. We've got minus 5 and minus 6. Careful with those two. Um, we got to get a negative 6 in here. That's going to be minus 6 and plus 1. That adds up to be negative 5. So remember what happens next. You don't have to show any other work. You should know the answers. But remember, this is called the zero product property. This is just the big idea for any factoring. Why do we factor? We factor to make separate factors, separate pieces here. They multiply to be zero. They must equal zero. That means each one separately could be equal to zero. That's the only way to multiply and get zero. So we're really thinking x minus 6 equals 0, but we get x equals positive 6, or x could equal negative 1. Two solutions on this one for that quadratic. So quadratic's couple solutions on here. All right, number 2, remember that these always have to be equal to 0. And so always get that first when you're going to factor. It doesn't do any good to factor if it's not equal to 0 first. Remember a GCF on this. If you factor out a greatest common factor, say we factor out a 3, we've got 2x squared minus 5x minus divided by 3. We've got 12. Now, that 3 does not have a variable. We're solving for x. That means that 3 doesn't have anything to do with the answers. In fact, we could just divide by 3 on both sides. 0 divided by 3 is still 0, and it's gone. So a greatest common factor that's just a number, a constant, and no variable, does not give you any separate answers. We just have to factor what's left. So we've got 2x, we've got x equals 0. Let's see if we can make 12 happen. What are some ideas that we can get for that? We can usually try 3 and 4, 6 and 2. If I go 4 and 3 on this one, I don't want to put the 4 with the 2. We've got 8 and 3. If we do minus for the 8, 4 times 2 plus 3, that looks like a minus 5 in the middle. So if each of these are equal to 0, remember the shortcut. We've got subtract 3 divided by 2, negative 3 over 2, or x equals positive 4. So there's our two solutions there. Number 3, now it gets a little bit longer. We've got an x cubed out of this one. So remember all the types of factoring that we have. Again, if you're going to factor, it's got to be equal to 0. So 3x cubed minus x squared plus 12x minus 4. 4 terms, the only thing we can think of is grouping. So the first one I have an x squared in common 3x minus 1. And plus we can take out a 4, and we're left with 3x minus 1. Now you get this x squared plus 4, and 3x minus 1 equals 0. 3x minus 1 technically our greatest common factor, but that's how we do our grouping on these. And 3x minus 1, that's easy. We got x equals positive 1 over 3. X equals 1/3. We do have to look at each factor. X squared plus 4, remember what we're doing. X squared plus 4 equals 0. If you subtract, we get negative 4. Try to square root, we get those imaginary answers. So there are no real solutions over here. Now remember, square root of a negative is the I. This is going to be plus or minus 2I if we are looking for complex answers. But if we're just looking for all real answers, 1/3 is our real answer. That's what we're going to look for most of the time on this. Number 4, it's already equal to 0. It's already factored, almost. But when we have this multiplication piece, these are each factors. There's a factor of x plus 2. If I have that, it's multiplied along with the others, so those are factors. We can just say x is negative 2. This x squared out front, or the 2x squared, the 2 doesn't do anything, but the x squared says that could just be x equals 0. In the middle, this is cubed. Now, this is just a bigger one that's already been factored for us. What we have to remember is the cubed here, if we're just solving, doesn't really mean anything. It just means this factor is here 3 times. They're all going to have the same answers, but we just have to solve 3x squared minus 5x equals 0. Each factor is really its own little problem, no matter how complicated it is. That cube just says it's there 3 times. This answer will, um, I guess, just have a multiplicity of 3 is what it's called. It just means it's there 3 times. Kind of goes back to bounce, wiggle, cross, if you remember that. Let's solve this. This factor is on its own. We can take out an x and have 3x minus 5. So we actually have an x equals 0. We're not going to need to list it twice in the final answer. And we're going to have x equals positive 5 over 3. So our final solutions for x, we got the 0, we've got the 5/3, and we've got the negative 2. So this is factored. 3 factors. 2 of them are simple. One of them just takes more factoring. It's actually not completely factored. Everything in here in the middle, though, is there really 3 extra times, or a total of 3 times. You don't have to list the same thing many times, though. All right, so think about this one. Doesn't matter how big each piece is. If it's factored, solve each piece separately. The 6, yeah, no solutions there. There's no variables, so it doesn't matter. Uh, x squared plus 5x plus 6 doesn't really matter that it's here 4 times right now. We're just going to solve the inside. That's x plus 3x plus 2. So we get answers of negative 3, positive 2. X cubed minus 1. We might be tempted to factor that, but a cubic, if we just say x cubed minus 1 equals 0, that's x cubed equals 1, and the cube root of 1 is just 1, no plus or minus. That's the only answer in there. So if you factor it into those difference of cubes, you'll have an x minus 1, which gives us 1, and a quadratic, which will end up with no solutions. So x cubed minus 1, you can just solve it and factor. It doesn't really matter that the squared, that means just 1 is here twice. X squared minus 3x, it's not completely factored. That's x times x minus 3, which means x equals 0 or 3. So we have 1, 2, 3, 4, 5 different solutions on this one. So as long as it's factored, each factor can be solved on its own. That's the whole idea of factoring. All right, number 6, let's see. Get a 0 on the left side would be easiest. Keep that x squared, the lead term positive, minus 6x plus 3. If I try to factor this, I'm going to fail. X squared minus 6x plus 3 doesn't factor. You can try all you want. You can't get things to add up to negative 6 that multiply to be 3. So what are the other choices we have? We should know the quadratic formula. So quadratic formula, solving a quadratic. To solve for x, we've got negative b plus or minus square root of b squared minus 4ac all over 2a. There's our quadratic formula. A, B, and C are the coefficients. That's one way to solve this. We could say x equals. B is the negative 6. So we're going to have 6 plus or minus square root of, do it in your head, is 36 b squared minus 4 times A is 1 times C is 3. And don't forget, all over 2 times 1 is 2. So 6 plus or minus square root all over 2. Figure out the inside first. 4 times 1 times 3 is 12. 36 minus that is 24. 24 reduces to 2 root 6. And when you divide, you've got to divide both pieces. Don't divide this 6 by 2 first and just leave the 24. You also can't divide the 24 by 2. It's in a root. So we're in a radical. Now we can reduce both of these and get 3 plus or minus square root of 6. So that's one way to answer this problem. If you remember, the other way is we could complete the square, which means if we get this all on one side, or at least 2 pieces here, I'm going to leave the negative 3 over here. If we have x squared minus 6x, I'm going to look to add something to this side. Plus, what would make that a perfect square? Balance it on the other side. Half of 6 is 3, squared is 9. We end up with x minus 3 squared, a perfect square trinomial. Over here, we add 9. We got to add 9 to this side. We end up with this 6. Square root both sides. X minus 3 equals plus or minus root 6. And add that 3. So we have 3 plus or minus root 6. Not always the easiest way to do it, but I just wanted to remind you of that option that we have of completing the square on some problems. Works easiest when we have a 1 for in the a value for the x squared, and the middle is even because we can cut it in half evenly and square it. All right, looks like that's the end. We have factoring quadratics to solve. And remember that quadratic formula to solve for the other problems if you can't factor. All right, that is 0, 3. Good luck on those. We'll see you for 0, 4.